Okay, this is the first CNC lab here we're looking at this morning, and I've already uploaded a part from SolidWorks, so I'm through that in the lab, how to model a part in SolidWorks and then upload it here into your Fusion 360 folder. So we've uploaded it here. The next thing you find when you upload it is we have to change from design option in Fusion 360 to manufacture. When we change to manufacture, we get a different list of commands, and we're looking at this component here as a milling operation. We're going to carry out a number of milling operations on the component. So the first thing you do is we basically work from left to right as we need, and again we're working on the milling tab here as opposed to the turning, additive manufacturing, inspection, fabrication and utilities. So let's look at milling first. So we're going to do an initial setup for the program. We get our pop-up screen here for the setup. First of all, what we select is a machine, so we can select it here. I've already got a Hurco VM10 selected that we have in the lab, but in addition to that, if you don't have the Hurco on your list, some students mightn't have it on the list, you can go to Autodesk and you can go to Autodesk generic 3-axis machine, which is fine. Alright, you can use that and hit select. And don't bother downloading the model that's used in simulation. We'll go through that in a more advanced lab. So we have the machine selected. The next type is a milling operation. That should be correct. And the next thing to check is the WCS, the work coordinate system here. And you should have this model in SolidWorks that your Z is along the axis of these holes, like we see on the screen here. X and Y doesn't really matter if it's in the other directions. But Z must be the depth of the part. Okay, so we can see here, if we spin that round, we can see that the Z is the depth, okay, as we have in the machine, and that's important. So just escape there for a second. I can move the origin to a corner like I would have in the milling machine, but that's not overly important. We could leave it in the middle, but we're going to leave it here at the edge. This top left hand corner is the origin. It's again Z in the vertical direction. The next tab we look at is the stock size. Now we can do relative size and just add a millimeter, but we need to look at it in reality. So what we do is we use the fixed size box, and our X width, okay, is this direction here, is 50 millimeters. Our Y width here is 60, okay, and that's based on the center. So we've equal stock left and right of the part. So you see the yellow stock around the component. This is the material you'll have to move. My Z height here, I think I had it at 13, so we might actually have, for example, half-inch stock, which is 12.7 millimeters, but we'll leave that at 13 at the moment. And we don't want the Z to be equal top and bottom. We want more stock on the bottom of the part because we have to hold it in the vise. So we offset from top, okay, which is the top of the part here, and we offset by maybe just a millimeter is fine. Now we need to check that. You can see it jumping on the screen there, but it's important that you check that. And you can see that the stock there is just slightly above the CAD model. Okay, a millimeter above, and I think this is 10 millimeters apart, so we have 2 or 3 in the bottom, which is sufficient to hold it. And the next one is part position, but I'm not going to move that. That's fine. We can leave that where it is. That's a new command, and then post-process we'll leave that for the moment. We'll come back and look at them when we export them to the machine. So that's the machine setup, okay, the setup for the program setup. The next thing we're going to look at really quickly is we just have 3 operations in this. We have a facing operation, which is on the top, which is going to machine that top surface. We have a 2D contour, which is to go around to give us the shape, and then we have to drill the holes. So we can look at these commands here on the 2D, milling 2D, and there's a few ones here. We'll start with the face option here, face milling operation. And as soon as we hit the face milling operation, again, we get this dialog box and preset. So the first thing we always do is, there's a number of tabs here. We'll just work our way over through the tabs. The first one is the tool. So we just hit select. And for the face milling operation, we want to use a face mill. So we can, over on the right hand side here, on the select tool library, we can actually use a filter. So this will only show face mills. And normally I have some just historic ones here in my setup, but if we go to Fusion 360 library and I have face mill selected here, I have just 2 standard face mills, a metric and an imperial. So we always stick with metric for sure. And we use this diameter 50 face mill. So we have it here and we just hit select. Now as soon as we select the face mill, we see it on the screen here popping up. It's quite large there, but that's the size of 50mm diameter face mill. The feeds and speeds here, we'll leave these as the standard ones at the moment, and we'll look at them in the lab later on about calculating out how we actually calculate out the RPM of the spindle of the cutter and the speed, the speed at which it travels around the part. So the next tab we look at geometry. And if we don't select anything, it automatically machines the stock. So this yellow square would represent the stock, and that's fine. We can leave it like that, so we're good to go. The next is our heights, okay, and we have 1, 2, 3, 4, 5 heights. We've clearance height, retract height, feed height, top height, and bottom height. Leave the first two alone for the moment. We'll talk about them maybe again, but the next three are kind of important. So the feed height, it goes from the top height, and it's 5mm on an offside. The top height then this is the top of the height that you want to start machining at. So we're going to say we're going to machine at the top of the stock and reference 0mm from the top of the stock. Remember, the top of our stock is Z equals 0. Okay, and you can see that on the screen there, top 0mm. All right, so that's where we start machining. And if we go to the next tab down here, bottom height, and it says model top, so it's going to the CAD model. So we set the CAD model a millimeter below the stock, or really the stock a millimeter above the CAD, and we have our Z0 is on top of that stock. So if the model top here is reference offset from the model top is 0, and we can see the bottom height then on the screen is -1mm. So we're just going down to 1mm. The next two tabs the next tab is the pass. Okay, so it's to do with the direction and extension. So normally we want to extend past the stock. Okay, so if you look at here, this pass extension here, the wee screen that pops up, the amount of the distance past the stock that we want to go, and we normally want to go. We'll just do about 10mm, and we'll have a quick look to see what that looks like when we hit simulate in a minute. Okay, so that's the only one I'm going to change for the moment. And the next one is linking, which is how it comes in and how it comes out. So I think we'll leave that as it is at the moment. I think that's okay. So if we hit OK on that, it takes a few seconds and it calculates out the actual operation. And you can see here it's at 0, and there's it calculating it out. Now it's going in the Z direction. I want it to go maybe in the Y direction. So we can give that a quick simulate. I'll just hit play there. Okay, and you can see it machining around there as such. Now, you can check some things there, but just going to turn off machine there, and the stock is fine. So close that. So if I want to go in and change anything in my settings after seeing that, so let's say I want to attempt to make it go in the Y direction instead of the X direction, the longer direction, I can just right click on the operation and write edit. So I'm back to where I started here. And if we look here, the geometry, if we look at the, let's go here at the passes, and we see the direction. Okay, and there should be pass direction. It's 0 degrees. So if I just change that to 90 degrees, I should go in the Y-axis. So I'm machining along the longest direction of the part, which would be better preference. Okay, and you can see now it's changed its direction there, and it's going along the Y-axis. And again, I can right-click on that and simulate to quickly check my operation. Okay, and there's the part, the top of the part done. So hit close on that. So I'll quickly move on then to the next operation, which is to machine around the part. So it's in the 2D operation again, and it's a 2D contour. And it's quite similar again. We'll go through the exact same steps, only with a different tool. Now it already loads up the previous tool here in the command, so I'm just going to hit select. And this time I'm going to use an end mill. So I'll go up here on flat end mill is the filter I'm going to select. And I go to 360 library, and again I just want to go down to the metric tools, and you can see diameter 3 right up to various diameters. So I want to select something large like diameter 16. So normally the larger the diameter you have, the longer flute length. Okay, so this yellow part here, or orange part that we see here. So I'm going to pick the diameter 16, quite large, and hit select. Okay, the next one, I'm going to leave again the feeds and speeds. We'll talk about them in detail in the lab, and methods of calculating them out based on material and tools. So geometry is the next one. So what we do is we actually use the contour. We select the top contour. You can see the top of the part being selected, and the red arrow is the direction of travel of the cutter. That's fine, and that's all we have to do there on that. Okay, we can go with the heights. Heights are very important here. So we forget about the first two, the clearance height, maybe, and the retract height. We'll leave them alone for a second. This just be the offset. The feed height is it starts traveling at the speed at which it's going to cut at 5 millimeters from the top of the machining height. Okay, and this is this top height here. So I'm going to start machining at the stock top, but that's a millimeter above where the part is currently, because we're after removing 1 millimeter off the stock. But it's fine to leave that there if you wish. Okay, the bottom height then, okay, is how far we want to go down, and we want to basically go down the depth of the part. Okay, so if I say we'll go to model top, okay, and I'm going to say -10, quickly check that out, and I can just spin the part around maybe and see. So you can see I'm just going down to the bottom of the part. The part's 10 millimeters thick, but in practice I want to go beyond that, so I'm just going to go -11 millimeters, and that's important that we go beyond the part we want to machine. So when we turn the part upside down for op 2, so when we open the vise, take the part out, turn it upside down, we have material to skim off, and we're not left with a wee rim on the part. The next important tab is passes. So many passes do I want to take, and the key thing here we want to look on passes is, if I just minimize that, is we don't want to leave any stock. We want to do multiple depths. Okay, and I'm going to say the multiple depth here is 3 millimeters at a time in the Z direction. Okay, and I'm going to leave the rest alone as such. The next one is linking, and what I'm going to do on the linking is the lead in there, the lead in radius, and I'm going to increase that to 5 millimeters, and the lead in distance I'm going to make that 15 millimeters. Okay, because I want this lead in starting off the contour or off the part, so that's important. So I'm going to hit OK, and I'm going to check my simulation here again and see what happens. So see, it took a few seconds to the end. So this is this 15 here I left on the lead in distance, and then the lead in radius. So this radius I don't really care about, but I definitely care about this radius here as such. And we just right click and hit simulate there. I'll be able to see right click and simulate and hit play. This controls the speed here, the slide bar down the bottom. I can see it's taken 3 millimeters off, another 3 millimeters off, another 3 millimeters off. Okay, and then it's just gone beyond the part, and it leaves me, this part here is still clamped by the vise. Okay, so I'm going to just close that, and I'm quickly going to then look at drilling these holes. So we'll go over a wee bit further over to the right hand side for the drilling command, and we select the tool again, the exact same kind of tabs that we see previously. So I hit select. I'm going to go to standard library. I'm going to go to drill over here. Alright, and I'm going to go down to metric. Now if I want to just filter out all these inches, see it over on the right hand side, units, I want to just see millimeter units. Okay, so I think it's a diameter 5 drill bit I use here, and I'm just going to hit select. So again, it loads up predefined based on drilling aluminium, which we're drilling. Okay, different for different materials, different feeds and speeds. Like stainless steel will be totally different than aluminium drilling. The next one is our geometry, and we just select the holes. So we select 1, 2, 3, 4. The next one is our heights. Okay, so where we start from, we'll just close off the first two for a second. Our feed height is 5 millimeters from our top. Our top height is the top of the hole. I could say stock top, just to be safe. And the bottom height, I could say, well, I need to drill the whole way through. So I could say stock top, even though the stock is gone, the first millimeter is gone. And I could say -15. And I know I'm drilling the whole way through the stock, and the hole is true. And that's usually a good thing to do. The only thing I need to make sure is that there's nothing underneath the component that, parallel or something like that, that the drill could hit. So I'll hit OK with that again, and I can see the yellow tool paths. Okay, and I can see